So, today we will be talking about loops in Java. Loops are very useful, and there are many types of loops. Most importantly are while loops and for loops. So I'll be teaching you what a loop is today and how to use it. And also, hopefully, I will end on teaching you guys and testing your knowledge from using a challenge that covers and utilizes everything we've talked about so far. So I'll start. So first, I'll give a few definitions. The first is an indefinite loop, which is a loop that runs indefinitely until a break condition is met. And for example, some scenarios in which we would use an indefinite loop would be, for example, printing random numbers until a prime number is printed, or like printing numbers or printing something until like the user types something, a scenario or something like that, or until like another certain condition is met. And basically the format for writing an indefinite loop is you would use a while loop, and the while loop, if you do while true, the loop would run indefinitely because there is no break condition. The conditional statement would lie within the parentheses here, but since it's true, it is the condition is always evaluated to true, so it would never stop until you tell it to break. And break, basically what it means is it tells the computer to exit the loop, even if the condition is not met. So this allows us to create a loop that does not predetermine the number of times it runs, and instead, based on certain outside influences, for example, a random number generator or a user input, it can stop. Contrary to an indefinite loop is the definite loop. The definite loop is called definite because you know how many times the segment of code is going to be repeated, and it's set before in a conditional statement. And the conditional statement is set not by the user but by the programmer, and the programmer has the ability to change it and predetermine the number of times it runs. And some scenarios in which you would use it would be, for example, printing hello 10 times, or printing any statement a number of times, or maybe printing every prime number less than 100. And this would be considered a definite loop because the number is fixed in that it does not change based on random scenarios, because the number of prime numbers less than 100 is always going to be the same number. Another scenario in which you would use a definite loop, we will be talking about this later, it would be to add elements to an array, but I'll cover this in our later class when we talk about arrays. Yeah. So there are two ways to create a definite loop, either using a while loop or a for loop. But in general, you would want to use a for loop because for loops make it pretty easy to create a definite loop. So any questions on those two concepts? No? Okay, I'll go on. Okay, so now that I've kind of like utilized the few terminologies, for example, while loop and for loop a few times, I'll define it real quick and show you how it works. So basically what a while loop does is that it runs the coding side repeatedly until the condition between the brackets is met. So in other words, it's called a while loop because while the condition is not met, the coding side is run. I mean, no. While the condition is met, the coding side is run. So some possible conditional statements would be a Boolean, for example, true. So in this case, we can see why an indefinite loop would run repeatedly because if you test a conditional, for example, true, does true always evaluate to true? Obviously, it does, as it's a Boolean, and it's by definition true. So the condition would always be met. And in this scenario, the coding side would always run. So it runs repeatedly until a break condition that we set inside is met. So that's the basis for an indefinite loop. And some other scenarios in which you could use a while loop would be like a counter. A counter basically is a number that increments each time the loop inside is run, right? And how to use this counter is if the counter reaches a certain number, then the condition, for example, if I said the condition to counter is less than 100, if I increment the counter every time I run the loop inside, at some point, the counter is obviously going to exceed 100. So in that, at that point, the condition would no longer be met, so the coding side would no longer run. So that would be how to use a while loop for a definite loop. And here is a picture I thought that would make a bit of sense. So basically how the logic behind the while loop works is it checks the condition or the test. So if the computer determines that the test is true, then the coding side or whatever it calls the control statements inside would be run, and then it would check to see if the test is still true. It does this repeatedly until the test no longer is true, and then it exits the while loop and executes any code after it. And in an indefinite loop, the test is true by definition because the condition is true. So just keep on running the control statements until you break it. So does anyone have any questions on the while loop? Really? No questions? Okay. I guess this is easy for you guys then. I'll talk about the for loop next. It's a bit more complicated, but should be similar. So for a for loop, the format for loop would be for and then a left parenthesis and a right parenthesis, and within the parentheses, you have to have an initial condition, a test condition, and an increment. So how it works is the code runs inside while the test condition has not been met. For initial condition, you have to define some variable and set it equal to a value, for example, a counter, or like a variable I or something like that. In my example, I set x equals to 0. And then test condition would be if the test condition is no longer met, then the loop inside does not run. And the increment would be how much x increases or decreases each time so that the test condition can be reached or not reached. Someone asked, don't we use I for loops? No, that is not necessarily true. Any variable we create within a for loop is called what we call a temporary variable, in which that it only exists within the loop itself. You can call upon x anywhere inside the loop. In general, you would use I, J, whatever, but it does not matter because it's just a variable name. It would be the same as using like A, B, or even if you wanted to call the counter Bob or something like that. So there are many ways to increment it, but I'll show you guys what increment does real quick. So say we have a temporary variable, we call it counter. What counter plus plus? Counter plus plus is your basic increment, what you use 99% of the time. And what counter plus plus does is that each time the loop is run, counter increases by 1. For example, if counter starts at 0, if you do counter plus plus, after one loop, the counter would now be 1 because 0 plus 1 is 1. But if you want to be fancy or something like that, you could make it so that the increment does not increment by 1 each time. You can make it increment by any integer, positive or negative. For example, I do counter plus equals 3. That means that each time the loop is run, the increment is 3. So counter increases by 3 each time. So therefore, after one run of the loop, 0 plus 3 is 3. So counter would be 3. And then we can see that the same thing works with negative numbers. You can have an increment that's negative. So each time the loop runs, counter decreases. And again, if you want to decrease by 1 each time, you would do counter minus minus, which is basically the reverse of counter plus plus. And you can also decrease by a negative number, same number each time. So counter would equal -2 if you do counter minus equal 2. Keep in mind that if you set an increment in the for loop, it's the same increment each time. So if I run the loop one time, if counter plus plus after one time would be counter equals 1. If I run it again, it would become counter equals to 2. Why can't you unmute yourself? Because you have no need to, and I'm afraid of people distracting my class, and you can type any questions you have to me in the chat. In regards to your question about the 5th line of code, I just explained it. It's basically the same thing as plus equals in that you can increment by any positive or negative integer each time. So in my scenario, I decrease counter by 2 every time the for loop is run. So I would do minus equals 2. So does anyone else have any questions on increment? Okay, I'll use a diagram to briefly go over how for loop works again. So in initialization, you initialize a temporary variable to serve as a counter. What a counter does is that it provides a condition that changes every time the for loop runs, and to keep track the number of times the for loop is run and to exit the loop when after a certain amount of times it's run. So the next part in a for loop would be the conditional statement. And the for loop, like a while loop, always checks to see if the condition is true or false. If the condition is true, the variable, the temporary variable you define as a counter would follow the increment defined in the for loop statement, or the decrement. It could be any integer. And then it would repeat basically after running the statement. But if the condition is not met, the for loop exits, and basically you go on with your program. Some examples of increments would be plus plus, in which every time you run the condition, you increase the counter by 1, or you can also go fancy and change the increments to something like minus minus, which decreases the counter by 1 each time. So does anyone have any questions with for loops? Whoever keeps on asking me what minus minus is hasn't been listening, because I literally just said that minus minus is a decrement by 1 each time the condition is checked. Okay, I'll go on. So you can use a for loop. Yes, I can show how it is used in a full code. This notation looks like C++ notation. It is very similar to C++ notation. A nested loops contains a for or a while loop within another for or a while loop. So basically, a nested loop allows us to use a for or a while loop within another one. And basically, I'm just including this to show that you can combine them. So what it does is the looping side is run all the way through. Each time the outer loop is incremented by 1. So in this scenario, it would run 0 to 7, 0 to 6, increment by 1, run 0 to 6 again, and then keep on doing that. So, oh yeah, this is actually back form. Whoops. Yeah. In general, in nested loops, you have to use different variables. I messed up there. Whoops. Okay, so to test your knowledge about how loops works, can anyone tell me how many times the coding side would be run if I have this following nested loop code? Yeah, 35 would be correct. Note that if I just have the inside part, the nested loop, what we call the looping side, it would go from 0, 1, 2, 3, 4, 5, 6. And then when it reaches 7, the condition that 7 is less than 7 is no longer true. So it would run it 7 times. But for each of these each of the 5 times outside, the code is run 7 times. So in general, you would multiply both of the number of times they're run, and you would get 5 times 7 is equal to 35. So the coding side is run a total of 35 times. Okay, so before I move on, I'll show a few examples, I guess. Because someone wanted to see some. Let's see, since my screen sharing is paused. Whoops. Let's see. I'll share my screen. Okay. Hopefully you guys can see this. Can you see my screen? Okay, great. I'll create a new project just to start from scratch. So, how to use a for loop. So because you can do in a definite loop, you can use a while loop and a for loop to complete the same thing. So I'll do something simple first. Say you want to print every number from 1 to 10, for example, and you don't want to just write system.out.println1, system.out.println2, etc. Because if you have a number more than 10, that would take a lot of time, right? So you can use a loop so that the computer does it for you. So in this scenario, we'll do something like, for loop would be, I'll use I because someone mentioned it earlier. It's the generally you want to use I, but you don't have to. So we can kind of see how it works just by looking at the code. So the first time the, the for loop is run, I would start at 1 because that's what we initialize it as. So we can see that the system.out.println 1, which is print 1, right? But then after this is 1, we check the condition. 1 is still less than 11, so that's true. So it moves on to increment I by 1, and 1 plus 1 would be 2. So now in the second time going through the loop, I would now be 2. So 2 would be printed, and since 2 is still less than 11, the I would get incremented again and the loop would run until I gets to 11. And since 11 is not less than 11, 11 would not be printed. So every number from 1 to 10 would be printed. And we can check to see that this works. First, we see that there are no compiler errors, which is generally what we want to see. That's the first test. If there are compiler errors, that means that whatever you're doing is not right. And we can see that works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And this is much better than if we just want to print system.outline and then 1, 2, 3, 4, whatever, all the way to 10, right? So it's kind of intuitive, but we can also, yes, you could put I is less than or equal to 10. It would complete the same thing, but since you know that I is an integer, because in general you would use a counter as an integer, it would never be something like 10.5, for example. So after 10, if it increments by 1, it will go to 11. So doing less than 11 would be the same thing as doing less than or equal to 10. But perhaps you can have the argument that doing less than or equal to 10 is more intuitive for the reader because you're printing from 1 to 10. And note that you can comment here, prints numbers from 1 to 10, right? If we want to do the same thing using a while loop, you would do okay. So you have to first create a variable. So this would be how we do the same code using a while loop. And we can see that a lot of what we are writing here really mirrors each other. If we replace counter with I in this scenario, we can't because we would be repeating a variable, right? I'm not sure. You might be able to because they're not used in the same loop. But you can see how they are similar to each other, right? We have this statement incorporated here. We have the conditional statement incorporated here. And we have the increment incorporated here. So the while statement here completes the same thing as the for statement here, but the for loop is just more compact. And these two should do the same thing. I can test it for you real quick. I clear this first. And now I should print 1 to 10 2 times because I have the for loop and the while loop. And we can see that it works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So we can see that in order to do a definite loop using a while loop, it's basically the same thing as doing it for a for loop, but the for loop is just more compact. And in regards to doing increments, we don't have to do plus plus. You could do something like plus equals 2 to increment it by 2 each time. This will print out 1, and then what's 1 plus 2 would be 3, and then 3 plus 2 would be 5. So it print out 1, 3, 5, 7, 9. And then once it gets to 11, the condition will no longer be true. And that's that. And yeah. I can show you what different increments do, I guess, real quick. Yeah, so it prints 13579 as predicted. So yeah. Does anyone want to see another example, demo per se? Or should we go on to the challenge? Because I think, yeah. If you guys have any more questions about loops, please ask. Okay, so no questions. So now I'll give you guys a pretty difficult challenge. So here's the challenge. The challenge here is to create a program that prints random numbers between 1 and 500 inclusive until a prime number is printed, in which it stops, right? And since we're talking about random numbers, I haven't told you how to generate a random number, so I'll give you guys a hint real quick. So math.random would return a random value x greater than equal to 0 and less than 1. So you can use this to generate random numbers between 1 and 500 by multiplying this function by 500, in which it would generate a value from 0 to less than 500, so integer values from 0 to 499. And if we add 1 to it, it would be from 1 to 500. But since math.random returns a double value which has decimal places, so you have to cast it as an int if you want to set an integer variable 10 equal to a random number. So with this in mind, you guys can start working on this. And for those of you that don't want to, or for whatever reason, I will go over some other math functions real quick. So last class we talked about the string class. So some other math class functions to keep not that are going to be used for this challenge per se, but can be useful in the future. Other than math.random would be math.square root x, which returns the square root of x, math.pow xy, which returns x to the power of y, and math.absolute value of x, which returns the absolute value of x. So now, at this point, hopefully you guys are able to work on this challenge, and hopefully for those of you guys that don't want to follow on and do the challenge yourselves, you can look and see how I do it. And for those of you that wants to try it, you guys can try your best to see if you can do it. And after the class, I will post a video of it, and you can see my solution and how I do it afterwards. So I'll do it real quick now. And yeah. Okay, so first I'm going to go over some of my thinking. So first we have to generate random numbers repeatedly until a prime number is printed. Yeah, I'm gonna pause on the challenge page real quick. So hopefully you guys have this. It's to create a program that prints random numbers from 1 and 500 inclusive until a prime number is printed. So first, we see that the keyword until a prime number is printed. This means that the number of times the loop is run will change every time based on a random value. So we would have to use a while loop here. So we write a while loop real quick. It would be an indefinite while loop until a condition is met. So while true, this would be an indefinite loop. And then now we want to generate random values. So to generate a random value, we follow the hint I gave, and we write something like this. right? So now, every time this loop runs, we have a different temporary value. And we want to print this temporary value. So we do something like system.out.println temp. So at this point, we can generate random integers from 1 to 500 repeatedly, and it will be different each time. Now, the next part of the challenge is the hard part, is to check to see if and when a prime number is printed. And when a prime number is printed, we have to break the loop and end the indefinite loop. So how do we check a break condition? We have to do an if statement, if break condition, right? So how do we check to see if temp is a prime or not? Well, we can check every single number from 1 to 500 and to see if it divides it, but that would take a long time for the computer, even the computer, to run. So we know that every single non-prime number, a composite number, can be written as two numbers multiplied together. For example, like 5 times 17, right? And there's always a smaller one of that. So to minimize the number of cases we test, we only have to test to the square root of 500, in which case that's like 22 point something. So we would have to test to 23. And if that doesn't make sense to you, you can search it up real quick. But I tried to explain why that works real quick. So, so we create a for loop. So if the number evenly divides any one of these, then it would be considered not prime, because a prime number cannot evenly divide any other number, right? So here we check. So it would only be prime if none of these conditions are met. So it would be not prime, right? So at this point, if it's not prime, we can break out of the for loop, right? Because if it evenly divides any of the numbers from 2 to 24, 23, it can no longer be prime. So obviously, we don't have to check any more numbers after it. So we break out of the for loop and we say that it's good. Otherwise, it is prime. So we set a Boolean variable, I don't know, Boolean prime equals to false. And if none of these statements work, if I reaches 24, that means that everything before it did not cause the for loop to break, so therefore it must be prime. In this scenario, we have to set the condition, what we're checking for, to be true. And if it is prime, we break out of the while loop. So let's see if this works, and after we check it, I can try to explain it a little better. Okay. Okay, so at this point, 239 should be a prime number. We check to see this. let's see. Shoot. Is 239 prime? Yes. So therefore, we can see that it works. When it reaches 239 and prime number, it stops. And all of these numbers before should be composite and not prime. And probably someone can verify it. So I'll go over my code real quick and I'll pause on it for those of this that wanted to try the challenge themselves. They can view this video from back home after the finish, where if they give up or something like that, and see how I did it. And so I'll explain it real quick. So first of all, we have an indefinite loop, and this only breaks if the number that we generate is prime. So now we have to write a for loop to check to see if the number is prime. So if it evenly divides any number from 2 to the square root of 500, you could do up to 500 if you really wanted to, but this saves some memory and some time. If it does that, then obviously it is divisible by some number that's not prime. So obviously it would break because it would be not prime at this point. Right? But if it reaches to 24, that means that it is has not broken yet. So that means it's prime. So at this